Now for 613. Will Mr. McBurney prove himself? So we've talked about Mr. McBurney and his free throw claim, that he is an 80% free throw shooter, but we're skeptical that he's really not that free throw shooter. So we are going to take another simple random sample of 50 to prove himself. So the P is the true proportion of free throws made by Mr. M. Your null hypothesis is that P is equal to 0.8. That is Mr. M is truthful. The alternative hypothesis is that he's exaggerating, so therefore that P is really less than 0.8. So a type 2 error in this setting is that, okay, Mr. M is a less than 80% free throw shooter, but we failed to reject the null, so we said he was an 80. We failed to reject. So our p-value came out where it was greater than alpha, so we failed to reject the null. So let's see what we can do here. So suppose Mr. McBurney's true free throw percentage is actually 66%. So therefore, our alternative is correct. We're going to put the information over here on the applet, and we're going to display the type 2 error. All right, so we are going to change our null hypothesis to 80%. We are going to do a less than because our alternative is a less than. We want to display the type 2 error, so I'm going to check box that one. And now we have that we know his actual. He's really only a 66%. So the true p-value is now 0.66. Our sample size is 50. And if I scroll down over here, it is going to show me the shaded region in this graph. So the shaded region is going to be our power type 2 error. The alternative was there. Excuse me. So if the HA is true, what is the probability of a type 2 error, which is our bad decision? So up here, I have zoomed in a little bit, so it's harder to see. Let me zoom over. So we have the probability of a type 1 error is 5%. That's the alpha. But the probability of a type 2 error is 24%. So this is 0.24. And then the power is what it is, what's the probability of us making the good decision? So our probability of the good decision is 76%. Every single time, I'm going to come over here and drag again for us. Every single time we do this, these two guys here, I can't draw those brackets. That's a little better. Every time we have this here, we have the type 2 error plus the power will always add up to 1. Type 2 plus power will always equal 1. So if we can find the power, or if we can find the type 2 error, then we can find out the other one. To interpret the probability of this good decision in context of the problem. So that is probability of rejecting the null when given that the null is true. So if Mr. M is a 66% shooter, free throw shooter, there is a 0.76 probability that we decide correctly that he was exaggerating. This piece here is our condition. And at the end, we are reject the null. Probability, rejecting the null, given the ha is true. So we're going to go back over to the website, and we're going to click on power. We want to increase the power of our test. Okay, so how could we adjust each of the following factors to increase our power? Use the applet to explore. So the first one, I'm going to go all the way over, as you guys have your paper. A couple things that we have. We could talk about the sample size. I'm going to talk about a few things, and then I'll go back and fill in the paper. So if our sample size changes, so say we go from 50 to 150-ish. I'll go 150. What happened to our power? If we increase the sample size, what does it do to our power? If you look up top right, it has our power is now 99%. So if we increase our sample size, the power increases as well because the variability goes down. If I go back to 50, if we changed our alpha, type 1 error is our alpha. So that's that bottom sidebar. So if we increase our alpha to say, I'll go 10%. If our alpha went from 10%, we're now at a power of 84. Go back to our 5%. We had a power of 76. So you increase alpha, we increase power. Go back to my 5%. Now, if we change the alternative, if I go up with the alternative true, if I increase that, my power decreases. So in order to increase power, we have to reduce the true value of P, reduce the true value of P, try to get to where it actually is in there, or increase sample size and increase type 1 error or alpha. So that is, we can increase sample size, we can increase alpha, and we can decrease the P. Each of those will increase our power. This sample size will decrease the variability. Which decreases overlap. For the alpha, if we increase the alpha, it makes rejecting the null easier. And then if we decrease the p-value, we increase the distance from the null. So our biggest thing is if we have our curves, I'll go like this. The overlap right here, which I don't have that much right here. This area would be this area up here as an overlap, so there's not much of it. Our power is the side on the left. So this is our 0.66, and this one is our 0.8. This is our null, and this is our power for the two separate ones. And our overlap is equal to our type 2 error. So now we'll finish this up and we'll review anything we need to in class. So the power is the probability that we reject the null given the alternative is true. If the alternative is true at one specific value, there is a power probability of finding convincing evidence to reject the null in context of the problem. So to increase power, we increase sample size, we increase alpha, and we increase the distance to the alternative. Increase the distance to the alternative.